So in this example, we're going to make use of the intrinsic property of specific heat to help determine the identity of an unknown substance. If you remember in a previous video, we identified or defined specific heat as the amount of heat it takes to raise 1 gram of substance 1 degree. And that specific heat is part of the heat equation Q equals mc delta T. So the last video we did 4 different examples using this equation Q equals mc delta T, and we calculated different parts of that equation. In this example, we're still going to use Q equals mc delta T, but we're going to be looking at 2 different systems instead of 1. The previous problems, we all had either 1 piece of aluminum or 1 sample of water. In this example, we're going to use specific heat to determine the identity of an unknown substance, but we're going to do that via an experiment that involves 2 different substances, one being the unknown metal and the other being water. So this problem, I think, is a great problem that illustrates this concept of heat. I have a star by it, so that means that it's going to be important for you to be able to do a problem like this for the exam, for the unit exam. But this kind of problem is a bit long for a quiz question, so there's not going to be a question like this on the Canvas quiz, but there will be one like it on the unit exam. And there's also another practice problem like this on the Canvas worksheets that you can try and work on your own. But let's try to identify the unknown block of unknown metal here using this concept of specific heat and Q equals mc delta T. So what I have done here on this slide is I've written out the problem, and with word problems, I like to write down, obviously, the variable and the measurement that I'm given to kind of organize the data that I'm given. I also like to draw a picture, my crude cartoon of a picture here. So in this problem, we have an unknown metal of mass 15.7, block right here. It's warmed to 53.2 degrees Celsius. So it has an initial temperature of 53.2. And I have plunged it or placed it into an insulated beaker. So think about this as like an insulated coffee cup. This insulated beaker has water, a mass of 32.5 grams of water, and it has its own initial temperature of 24.5 degrees Celsius. So I got all of that information from the first sentence in this problem. So I know that I've got some hot metal and I've got some cool water in a separate beaker that is insulated. It says the metal and the water are allowed to come to a final temperature of 27.2 Celsius. So this hot metal is placed into the beaker with cool water, and they both get the same final temperature because they're both in the same system. They both have the same final temperature of 27.2 Celsius. And then I also give you the specific heat of the water, but I want to know what is the specific heat of the metal of this guy. Sorry. And then once you find that specific heat, you can look in this table or in your notes to determine what its identity is. So what I've done here in this slide is to kind of map out the different variables I was given. On this slide, I have organized it such in terms of data given with regards to the metal and data with regards to the water. And I think that's important to do because it helps you to focus on, oh, my final goal in this problem is to find C, or the specific heat, for the metal. To find specific heat of the metal, well, I know my mass of the metal. I was given that. I can find my delta T of the metal, and in this case, that delta T is going to be negative. Why? Because it's always final minus initial. And it makes sense that my change in temperature is negative because the metal lost heat, right? It went from being hot to being cool because it contacted the cool water. That's why delta T is negative. So I know mass of metal. I know the change in temperature of the metal. I don't know the specific heat of the metal, and I also was not told the heat of the metal, the Q of the metal. Which would have been nice though, because if I knew Q of the metal right away, I could just solve this equation for C of the metal. I don't know Q of the metal, or the heat associated with the metal, but I do, or I can calculate Q of the water, the heat that's associated with that water. I know the mass of the water, 32.5 grams. I know the C of the water, the specific heat of the water, 4.184 joules per gram degree Celsius. I can easily calculate the delta T, or the change in temperature in the water, final minus initial. And so I can easily calculate the heat that is associated with the water. Why is that going to be helpful to us in the problem, even though the problem didn't ask us about the water, it asked us about the specific heat of the metal? Well, since the hot metal was placed in the cool water in an insulated container, when you think insulated, you think no heat can escape from that container. So what that means is that the heat that's associated with the metal, that heat is lost. That's why I've got a negative sign here. So the heat that is lost by the metal is going to be gained, that's why I've got a plus sign, gained by the water. And since that system is insulated, I should have typed this out, but since it's insulated, that means there's no heat loss to the outside, and that means that the heat absolute value numbers are equal. Why is that helpful and important to us? Hey, I can find my Q of the water very easily, and changing the sign gives me heat of the metal. Hey, I can use heat of the metal to calculate C of the metal, which is what we're going to do in this problem, which is, first, we need to find Q of the water. And we can do that fairly easily by Q equals mc delta T, mass of the water, specific heat of the water, delta T of the water. See our units cancel appropriately. And I'm not going to be picky with sig figs on this problem. Technically, my Q of the water should just have 2 sig figs, but I'm going to take it one more step further. I'm going to do 3 sig figs. If you just did 2, you would still get the same answer as long as you rounded properly. But multiplying these 3 into your calculator should give you 367 joules. That's equal to Q of the water, which is now equal to negative Q of the metal. So that's great. So now we can use our Q equals mc delta T of the metal, solving for C by dividing both sides by m delta T. Therefore, I can start replacing variables. So my C of the metal is equal to minus 367 joules. Again, it's negative because of this negative sign. And that's good because that negative sign is going to cancel out with the negative sign from the negative 26 degrees Celsius that we found up here. So when doing that division and multiplication, you get an answer that it's in joules per gram degree Celsius, which is good. That's a measure of specific heat. And so to 3 sig figs, that should give you an answer of 0.899 joules per gram degree Celsius. And if you go back to the table in your chapter 3 notes or in your textbook, you will see that this specific heat is closest to aluminum. So the probable identity of this unknown metal in this experiment is aluminum. So, as I said, this problem is too long for a 10-minute quiz question, But there will be a problem like this on the Unit 1 exam. And there's another one that you can work for practice in the Chapter 3 Canvas worksheet that I've posted.